All right. Well, this is a different type of talk. And just to clarify with the introduction, I was an assistant professor of computer science. I am no longer. I am a researcher in the Hugh Call Precision Medicine Institute at the University of Alabama, Birmingham, working with Matt Might, applying functional and constraint logic programming to precision medicine, which is very interesting work. But now I'm going to talk about something apparently very different, although there are some similarities. So Boodle years ago sort of dared me to give this talk, and I hemmed and hawed for years, and I finally broke down and agreed that maybe with the pandemic, this is a good time to try something a little different. And so the thing that I had claimed over and over again was that if you really study the way StarCraft players learned StarCraft, you would learn things that could be applied to learning programming and becoming a better programmer, or learning how to teach programming better. And Boodle thought that that was an interesting enough topic that it was worth having me actually prepare a talk on it. And so this is the first time I've ever given this talk. It's the first time I've given anything like it. And I'd be interested to get your feedback. This is mostly an idea talk. I will show you something I've been working on a little bit, sort of inspired by some of these ideas. But this is trying to propose a way of thinking about learning programming, thinking about how to improve as programmers ourselves, how to teach programming in a different light, inspired by what I've observed by people who are good at StarCraft, people who are good at chess, people who are good at Go, and other things like that. And also just my own attempts to learn difficult things like Japanese. So, but I'm going to try to focus it on StarCraft, because that was the challenge, was to give a talk on StarCraft, what we can learn from StarCraft players. Now, I'm not sure how many people here are familiar with StarCraft. I'm sure some people are and some people aren't. So StarCraft is a real-time strategy game created by Blizzard, and which is now Activision Blizzard. And this game is about 20 years old. I think the original StarCraft is about 22 years old now. There was an expansion called Brood War, and there's a new version called StarCraft 2 that came out around 2010. Okay, so that we have a 22-year-old version of the game and a 10-year-old version of the game. And this genre of game is real-time strategy game. And so there have been many other real-time strategy games that maybe you're familiar with. There's one called Age of Empires. There's another one called, there's the Warcraft series, also from Blizzard, that World of Warcraft was based on, like Warcraft 1, 2, and 3, Command and Conquer series, or many of these types of games. And you can trace their history back to a game called Dune 2. And before that, you can argue that there were real-time strategy elements in games like the Ancient Art of War from Broderbund. So it's an interesting history. One reason the history of the game is interesting is that this particular game, StarCraft, the original StarCraft, it turned out it came out at exactly the right time to be adopted extremely widely in South Korea. And this became sort of the first major e-sport, electronic sport in Korea. And it was the first computer game where you had a very large number of professional players who were working at the game full time. So at its peak, there were something like, well, I don't know how many teams there were, but there were many players in Korea who were training full time and playing in professional tournaments for significant amounts of money. And there were actually television stations. There were 2 television stations in South Korea that only showed StarCraft matches. And the most famous players, like Slayer's Boxer, were huge celebrities in South Korea. Something like half of all copies of the original StarCraft were sold in South Korea. And because South Korea, the population tends to be concentrated in Seoul, you had this interesting confluence where you have a very, very high concentration of very skilled players. This was the same time that Seoul was getting high-speed internet. And you just had this sort of perfect mix for a new game coming out where people became very good. And a lot of infrastructure developed around the game. You started getting team houses, coaches, television stations, high-level production, high-level commentary, and the game, sort of went on from there. And then when StarCraft 2 came out, that was the first video game specifically designed to be a competitive, professional level esport. And that really ignited the esports scene in the West. There were other games, Counter-Strike and the fighting game community and so forth, but this is the one that really set things on fire in the West. And then now, things tend to be dominated by, League of Legends became extremely popular. Now there's Fortnite and so forth. But even if you trace back League of Legends, you could see that League of Legends is basically a version of something called Dota, Defenders of the Ancients. And Dota was a custom map for Warcraft 3, which was itself a version of a map ported over from the original StarCraft. So much of the esports scene today, which has now become a gigantic multi-billion-dollar industry, can be traced back to StarCraft in South Korea. And so to me, what's interesting is you had in a very short period of time an extremely intense community of passionate people who wanted desperately to become extremely good at this game and work at the professional level. The game itself is somewhat constrained. The rules are fairly simple. There's only a small number of units and combinations in some sense. In that sense, it's similar to chess or Go. It's a little more complicated, but it's not massively complicated. And you had people who were sort of like professional chess or Go players. But the scene exploded in a very short period of time. If you track Go back, that game has been played with effectively the same rules for thousands of years. Chess has been played with effectively the same rule for hundreds of years. And here is a game that didn't even exist, 23 years ago. The professional scene with coaches and team houses and sponsors and television networks and so forth exploded within a few years. And people got very good at the game very quickly. And they have continued to improve. And at the peak, the professional players in South Korea were contractually obliged to practice at least 12 hours a day. And in practice, many of them practice more than 12 hours a day, and that's 7 days a week. Usually in a month, they might get 2 or 3 days off. So that was the level of intensity. And my hypothesis is that whenever you have a group of people who form a community who become that intense at becoming the very best they can, and because StarCraft is a competitive game, you can easily measure who is better than someone else. And in fact, there's like an ELO rating, effectively an ELO rating like in chess, so you can actually numerically quantify how strong people are. Whenever you have that sort of environment, and there's tremendous pressure to be the very best or one of the top 10 in the world or whatever, people have to start understanding how to become better and how to become better efficiently. And so becoming better efficiently is extremely important. One of the things that you learn if you study StarCraft or you play StarCraft is that two players who are new to the genre, new to the game, can both invest the same amount of time, and one player will end up in Grandmaster and the other player will end up in, sort of like Gold League, sort of a low-level league. And so what's the difference? If they invest exactly the same amount of time, what's the difference between someone who gets to Grandmaster level and someone who's stuck in gold forever? Okay, so that's interesting to me. Another thing that's interesting is the way people have developed sort of meta-level thinking about how to learn and how to teach this game. I think that's interesting. And then a third part is StarCraft 2 in particular is internet only probably for reasons related to piracy. I think that's the real reason. You have to use the Blizzard servers. You have to have an internet connection to play that game. And because of this, and when the game came out, or basically in the West, people were getting high-speed internet, the way to explain the game, the way to teach the game is highly visual. It's all internet-based. This is about the time that YouTube was becoming really popular. It was about the time that Twitch came out. In fact, Twitch TV, which was bought by Amazon and is now a huge endeavor and used by programmers to stream their own programming. Maybe some of you have streamed on Twitch. That actually started as something called Justin TV. And Justin, who founded Justin TV, was an avid esports person. And it turned out that Justin TV was a way to live stream yourself doing whatever. And once StarCraft 2 came out, basically the popular streamers were StarCraft streamers, and they decided to start Twitch TV, sort of a spinoff of that. So this was about the same time that StarCraft came out. In fact, I saw a StarCraft tournament with Justin at the Mad Dog and the Fog in San Francisco, sort of at peak of StarCraft 2's popularity. So anyway, this game came out, StarCraft 2 came out just when in the West, the high-speed internet was becoming readily available, and streaming services where you could stream yourself were becoming readily available. And there was a whole generation of young people who grew up playing these games and learning from each other and teaching each other. And they are, true digital natives, and not just digital natives, they were YouTube natives and Twitch natives. And they have figured out how to communicate these very difficult skills in ways where I still think if you watch, let's say if you watch one of the MOOC courses and you see a professor trying desperately to figure out how to communicate complicated ideas, still trying to figure out how to turn on a webcam, and then you watch, an 18-year-old trying to teach someone how to play at the high level in StarCraft, you'll see that one of those two really understands the media in a way the other doesn't. So that also fascinates me. Okay, so in order to remain concrete, what I'd like to do is, first of all, just show you a small amount of StarCraft 2 gameplay, just because otherwise I'm going to be talking about things that may be unfamiliar to people. Okay, so I'm just going to play one short game against the computer. Hopefully this will all work with the screen sharing, and then we can kind of talk about some of the things we're saying. Now, I've set it up so hopefully you won't hear the fans running on my poor little laptop that's trying to play this game, and hopefully all the AV stuff will work. But let's see what happens. Let's get it started up. All right, so let me do screen sharing. All right, and you can see that there I have Warcraft 3, StarCraft 2, and the original StarCraft. Let's play StarCraft 2 here. And hopefully this will start up in a windowed mode. Okay, great. All right, so let's just play a quick game against the AI. I will play as Zerg, which is my main race. So there are three races: Terran, Protoss, and Zerg. Terran are the humans. They're like the space marines. If you think of the movie Aliens, they're like the marines, space marines and aliens. Zerg are the bug creatures. They're like the alien in Aliens, and creepy crawlies. And then the Protoss are like sort of the world of the war of the worlds, like, super advanced aliens that have a huge amount of technology. So I'm going to play the bugs, and the bugs have a lot of cheap units that are pretty weak. And if you've heard the term Zerg Rush, that's where this comes from. The idea that you just build a whole bunch of cheap units and overwhelm your opponent with that. So let's see if I can. Okay. All right, so this is my Zerg hatchery. So I have buildings. I have an overlord, which I'm going to scout off and send off the scout. And so this is the building where I can make units. So now I'm making another overlord, and I'm making these drones, which are workers. And you can see I need to spawn more overlords. So there's this notion of supply. I'm at 14 out of 14 supply. So in order to play this game, you have to balance a whole bunch of things. So you have to balance making workers versus making sort of fighting units. You have to do things like build buildings. Okay, so here I'm building a spawning pool, which will allow me to make Zerglings. I can build an extractor so I can mine gas. And I have different sorts of buildings. I can build different sorts of resources. Actually, in this game, there are only two resources. So there are minerals, which I'm mining with these workers. And I will be mining, gas. I can also do things like scouts. So I'm going to send this worker, which I can right click, tell it where to go, and I'm going to send it across the map, and I'm going to click on this part. Now you can see that the map is dark because I don't have vision. Okay, so this is called the fog of war effect. And let's see, I'll go ahead and put some workers and gas here. And I think I'll do just a Zergling rush. Okay, and I can also make a separate second hatchery if I want. One thing that may not be apparent is that I'm hotkeying, and you can see my hotkeys down here. Okay, so I can hotkey a drone, and now I've got a hotkey number 1. I have hotkeyed my main hatcheries to 4, so if I double click on 4, I immediately jump back to the hatcheries. And I can actually, without even looking at my own base, I can hit a hotkey, so 4, and select my larva, and then make 3 Zerglings. And then I can rally the Zerglings to my opponent's base. So I can do all that without looking at the base. And so this is a very important skill, is getting used to the hotkeys, being able to perform actions, sort of with muscle memory and as quickly as you can. And so, in fact, one way you can measure the speed of the players is what's called actions per minute. And a really good player in StarCraft might have as many as 400 actions per minute, which is something like 8 actions, 7 or 8 actions per second. That's amazingly fast. Okay, so now here I am going to send my Zerglings over to fight against the Terran. There are, at a high level, you can think of a couple things going on. First of all, there's what's called macro. Macro is me doing things like building units and building buildings, teching up. Here I'm researching a upgrade to my speed for my Zerglings, and I'm producing more Zerglings. I'm mining these minerals, and I can expand and so forth. There's another part of the game which is called micro, and the micro is moving around individual units sort of optimally, or as close to optimally as possible. Okay, so you can see the AI is microing this worker, and here I've got these Zerglings I'm going to try to micro. And so I can control those Zerglings individually if I want. I can take one Zergling, box select it, and say, hey, you go over here, and take these 2 Zerglings, and I say, okay, you're going to go up there and try to attack or something. Okay, so I can control my units, and if I'm really good, my control of the units will be far better than what the computer can do. Okay, so there's the micro and the macro, and this game is designed so there are really too many things to keep track of at once. You have to spend your attention efficiently, and you have to pay attention to, are you expanding? So here right now I have 1,500 minerals. That's way too much. So I could do something like expand to my natural base. I'll build another base here. I can do things like make more units. I can go ahead and build a roach warren and whatever. I have to pay attention to all those things. Okay, so that's sort of enough high level to just give you some sense of what's going on in the game. And so I'm still fighting. Okay, I basically won against the computer, and you can see the computer has said GG, good game. So I've won. And so I will accept my opponent's surrender. I've won the game. Now this is what's interesting. I can go to the score screen for the game, and I can see how well I did according to various metrics. So first of all, my performance, I can see what my actions per minute are. I had 51 actions per minute. The computer had 82. If I were playing for real, it would probably be for me around 110 to 150, depending on the length of the game. For a pro player, it'd be about 400, probably 350, 400. I can look at the graphs and so forth, the build orders, to see which order my opponent was doing. So if I want to copy their build, if I think the way they built the units and the structures was more optimal for the type of strategy I want to apply, I can do that. But the most important thing is I can click on watch replay. And watch replay brings me back into the game. And now I can look at the game from my opponent's perspective, or I can look at the game from the perspective of, you know, some an entity that can see everything. And I can also do things like speed up. I can do things like speed up the game. So I can say, okay, do I want to have the vision of the AI? Do I want to have the vision? Okay, so here's what the AI is doing. And I can go back and I watch it, and I can pause at different points of time. And so I can do something like pause at 2 minutes. I can pause at 2 minutes, and then I can go back to my point of view, and I can say things like, okay, let's look at this, and how am I doing in terms of my resources, my supply, how many units I have. And in fact, I can look up here and I look at my units. Okay, so I can say at about 2 minutes, I had 18 drones and 2 overlords. I had a pool. I was starting a second hatchery. I had this many minerals. I had too many minerals. I should be spending them. And so I can go back and I can analyze this. And I can also get replays from pro players. Okay, so this is a sort of infrastructure that's important to allow me to improve. The other thing I can do is I can say, the game itself supports several different learning modes. So for example, if there's a campaign mode where I can go through and play, you know, effectively against computer in hand-built scenarios, this is what actually most people do. They never play on ladder against other people, but the campaign is very well designed. It's designed by you know, some of the best game makers in the world, and what it really is doing is teaching you new skills and helping you level up. I can also do things like play training. They're training modes specifically to allow me to work on specific skills. Okay, so all those things exist. All right, now I'm gonna get out of StarCraft and I'm gonna talk about a little bit about how this might tie in to becoming good about programming. So the first thing I would say is, you know, one thing you notice when you start studying StarCraft is that there is, you very quickly realize that if you think you're good and you've played a lot and you've trained and you've read forums and you've watched videos of pros, and then you play someone who's really good, that the skill ceiling of the game is effectively unbounded. People keep getting better and better at this game. And because you can compare it numerically and because you can see how the strategy evolves over time, is very clear that people who are considered the best in the world, you know, 5 years ago, 10 years ago, today, if they played, would be looked at as clowns. In programming, we don't really have the ability to so easily compare skill levels. But I don't have any reason to think it's any different in programming or computing or in you know, things like software engineering than it is in something like StarCraft or Go and chess. And if you read the book Peak by Anders Ericsson, he makes the argument that actually in almost all fields of human endeavor, except some which are bound by physical limitations like maybe running the mile, there effectively is no peak performance. People keep improving over time. And so this is like a very important lesson. Every once in a while as a programmer, I would program with someone who was able to do things that I just didn't believe were humanly possible. And that sort of reset my idea of what the skill ceiling was. And I think it's important for us to all keep in mind that all of us are in this situation, no matter how good we are, how accomplished we are, where we could actually be much, much better. And hopefully in the future, if we can have improve our discipline, then that will be the case, that tomorrow, you know, like 10 years from now, if we were to actually accomplish something in the way of training and education, the people 10 years from now or 20 years from now should be much more accomplished than we possibly could be. However, I don't think that's really happened with the way computer science education and training has worked. But anyway, the idea of the skill ceiling, I think, is very important. Another idea I think that's very important, probably the most important idea that I want to talk about today, is the idea of looking at StarCraft as a collection of mini games. So there's a gamer named Day9 who analyzes games. He's an avid StarCraft player, and he claims that the way to look at a game like StarCraft is a collection of mini games. So for example, there's a mini game which is building your buildings within your base optimally, or as close as optimally as possible. That is a mini game. How do you build your buildings? Another mini game is how do you micro your Zerglings, okay, to fight or to act defensively. That's an entire mini game. Another mini game is when do you expand? How do you spend your resources effectively? That's a mini game. And there are training maps and training tools available that people in StarCraft make. Part of this is built into the game in StarCraft 2, and part of it are custom maps that people make to help train themselves to become better, or help train other people. And when once I started thinking about this, I realized that that's actually the way I think about programming in a language like Scheme. The thing about Scheme that's similar to StarCraft or Go or chess is that there's a core part of the language, and this is true for languages like Erlang, and I think most languages. There's a core part of the language that if you really understand it well, you can effectively get away with doing most of your programming in that core language, okay? And there's a model of becoming good that I think a lot of people have, especially beginners, which is you become a good programmer by just learning lots and lots of stuff. You just learn lots of stuff, learn a bunch of languages, you learn a bunch of frameworks, and that somehow is what makes you good. And it is true that those are important things to do. It's important to have that experience. At the same time, all of the really, really good programmers I've worked with, the people I consider great programmers, they have a mastery of the core fundamentals of the tools and languages they use, which is exceptional. You can watch them work and you realize that the likelihood that they're going to make a mistake in Lisp, for example, of consing up a list is almost zero. They almost never make a mistake with the foundational skills. I'll work with other people who actually have been programming for a very long period of time, and I'll notice that they make lots and lots of little mistakes. They don't have that level of mastery. And I think the problem is that people, when they're learning, say, Lisp or Scheme, they think that, you know, probably having 95% accuracy, you know, not explicitly they'll say this, but it's like if they're 95% accurate, consing up lists, 95% accurate, extracting parts of a list using car and coulter, and all these other skills, 95% accurate writing recursion over lists, things like that, that is sufficient. My experience teaching Scheme and working with other people, and as a Scheme programmer myself, is that actually is insufficient. You should really be aiming for 99% or higher for all of the core skills and sort of the mini games, if you want to think of that, that compose, you know, something like programming in Scheme. And the reason is, as soon as you start working on something complicated, you're going to have to be consing up lots of lists. You're going to have to be taking cars and couters lots of times. You're going to have to be writing lots of recursive functions over lists, or you might have to be using continuation passing style or other program transformations. And if you're making little mistakes constantly, or if it's taking you a long time, then first of all, you're thinking at a low level. You're having to think operationally at that low level in fighting with your text editor because you don't know how to do prime matching or whatever it is. And then the other thing is you're going to spend a lot of time tracking down bugs or tracking down type errors because you're making these tiny little mistakes. And that's exactly what separates a pro StarCraft player from a merely good one. The main thing, once again, Day9 says, is that if you are a StarCraft player and you can execute 20 strategies well, you're a good player. If you can execute one strategy perfectly, you're a great player. And this is how it seems to me with a language like Scheme, where once you really understand the core language, becoming good doesn't just mean learning new things. It means that you're perfecting and honing those core parts of the language understanding and the language skills that are necessary to tackle bigger things. And I don't think that's the way programming is thought of. So one of the things I've started working on is a Scheme primer, and this is sort of named after the primer in Neil in the book The Diamond Age. Okay, so here's part of the primer where we can do consing, for example. Okay, and so basically it's going to randomly give me a little cons program, or a cons problem, and I can say, okay, I will cons this up by doing this. Okay, and it'll tell me if I'm correct or not. Okay, here's another one. So I'll cons quote car to the empty list to the empty list, quote the empty list, and it says I passed that one, and so forth. And so one of the things that I would like to do is start trying to build some infrastructure, start building tools like a primer that really exercise what I consider the fundamental mini-game style skills in programming like Scheme. I pick Scheme because it feels like Go or chess to me, but I think you could do the same thing for other languages, even for things like Java, where you also have an element of time and accuracy, and it's also incremental, and it tries to adjust the skill level based on how the learner is doing. And also the other last thought I'll have before we talk about the questions is, another idea I've been playing with is what would happen if we lived in a world where just like every RTS game ships with a campaign, which teaches you how to use the game and increases level of difficulty, and also has like training modes and training maps and things like that the community builds. What would happen if when you got a programming language installation or a compiler or something like that, if it came with something which was tutorial, but that was interactive and gave you feedback and gave you strategies for leveling up and gave you sort of mini game trainers that had the same amount of care lavished upon it as the compiler itself or the runtime system itself or language itself. What would that be like in terms of people learning the language? And also I think, training is sort of like a dirty word among most people. Okay, education is important, but training is also important. And training is skills like this in terms of speed and accuracy, because otherwise you don't have a foundation for building the higher level thinking. Everything kind of collapses. Okay. That's I could probably talk about this for 2 or 3 hours, but those are just a few of my initial thoughts.
Great. Oh, thank you so much, Will. Amazing talk, really insightful, really interesting. So I checked QA, we don't have questions there. Maybe somebody wants to unmute themselves and ask the question. Right, while we are waiting, I will ask a question. I really loved the idea where players could watch more experienced players. And I was wondering, how do you envision less experienced developers, software engineers, watching more experienced developers in this context?
That's a good question. I think some of that is starting to happen now through things like YouTube and Twitch. There are people who stream themselves building things, and there are things like Handmade Hero, if you've seen this series, where someone is building a video game from scratch, building the entire engine from scratch in C or whatever. So those sorts of things are starting to happen. I do think there's some resources out there like Beautiful Code that walks you through some code and so forth. But I think a lot of it is just kind of rethinking, what it is that we need to teach and how do we need to teach. I think one of the things I'd like to work on is starting to build videos and books and things like that are kind of integrated, where we work through solving some real problems. And then, one important thing is to understand the trade-offs, where it's like, here are 5 ways to solve the same problem, and also to understand the thought process. So there's a great series by someone named Apollo on StarCraft, where he plays a bunch of games and he's explaining to you his entire thought process. Vibe does another one of these series, and it's trying to explain all of the decisions being made. And I think that would also be a very useful set of resources, is trying to have really experienced programmers in a certain language and context, solving real problems. And what they're trying to do is explain all of their thought process. And this also gets into, there's a dichotomy in StarCraft between playing to win, like in a tournament, and playing to learn. Okay, and that's something we don't really have a dichotomy. We don't really have programming, the idea of continuing practice of experts continuing to program just to learn, where the entire idea is they're going to throw the software away. Some people do that, but it's sort of an ad hoc thing. We don't say that is the expected practice for everyone who's at a high level, is that they're constantly writing programs just to learn new techniques. Now there are plenty of people who do this, but this isn't something we talk about. Whereas if you look at something like chess and Go and StarCraft, this like everyone knows that that's how you do it, right? There's the training, and then there's the actual playing for keeps, right? And that's another idea. I think there are a whole bunch of ideas like this, and the idea of having a training plan or a training regimen that a coach helps you prepare with, that's another thing. Like, when I'm teaching someone scheme, I basically come up with a personal training plan for them based on where I think they are. And a lot of it's based on things like mini games. Like I'll sit there and I'll program with them. And if they can't do things like cons up a list accurately every time, I'll assign them a bunch of exercises. If they're having trouble, things like they need to understand environment passing interpreter so they can understand the semantics of scheme and things like that. So I have them work on exercises related to that. And there's always a speed and accuracy element of all those things. They want to keep getting better, keep being better at the things that they already know, not just learning new things. And also doing things like text editor, right? For like I use Emacs, and I've got everything optimized so that I will not make mistakes. Every time I find a mistake, I go back and try to fix the way I do things so I won't make that same mistake again. And that's very much like the mindset of a professional gamer. They don't ever want to lose the same way twice, the same thing. And there are some programmers like DJB who does this. Whenever he finds a mistake in his code, he changes his approach so he doesn't make it again. But it's a shift in mentality, I think, that's the most useful part of studying this.
Right, great. So we have a question from Thomas. Thomas, please.
Yes. Hello. So thank you for talking with that. I've been talking a recurrent thing with particularly online and StarCraft community for years. The thing that you mentioned a bit is the idea of having training in the game. But another thing I see a lot from StarCraft players and general players is that the game gives you a lot of information, right? In the sense that pretty fast if you are doing something wrong, right? You get punished pretty fast, or in game usually you get punished. And so you can easily adapt to that. And that's something we have begun seeing a little bit more, I think, nowadays. Like Rust, for example, with a compiler is a typical example of that, where we tend to have a more collaborative experience with our tools and our systems. And that's still pretty rare in software. Yeah. And do you think that's also something that could help learning better if we were going more in that way?
Absolutely. And I think if you, this sort of very fast feedback is really essential in order to improve your skills. And that's one of the things I want to do with the sort of primer idea. If you look at learning music, there's an amazing piece of software that's sort of like Guitar Hero, but for learning guitar for real. And I'm blanking on the name of it right now, but the idea is it gives you immediate feedback. When you're playing a piece, it'll immediately tell you if you're making too many mistakes, it'll rewind and slow it down, right? And so that sort of immediate feedback is super important when you're trying to level up. And so that's the thing I think is critical, is both the time, accuracy, and immediate feedback. Like those three things I think really have to come together, and you have to be able to measure it somehow in order to improve your skills. So yes, I think we can build the tools that would help people with that, but that's not the way you think about it when you think, here's a book with a homework assignment. It could take you 4 hours or it could take you 14 minutes, right? If you really want to become good at it, you should be getting to the point where you can do many problems of a similar nature very, very quickly with very high accuracy. And you should be trying to improve yourself and should be understood, like, kind of what an expert practitioner can accomplish in that area.